This is for U12 specialists. It comes out of the circular functions, complex numbers, vector trial number 6. It's question 10. It's all about scalar and vector resolutes. Remember, a scalar resolute is the amount or magnitude of A in the direction of B. So, if this is A and this is B, then this bit here is the magnitude of the scalar resolute of A in the direction of B. And the vector resolute is actually the vector that represents that magnitude. So how can we play with this? What I've got is B over the magnitude of B, which is the same as B hat. So that's the same as A dot B hat. And if that's the case, for the vector resolute, I know that B dot B is the magnitude of B squared. So this is the same as A dot B over the magnitude of B, another magnitude of B, B. And that this bit here is the same as what we've got up here. So I've got A dot B hat, which is a number, and that's times B hat. Now, if we're looking at question 10, it's actually B in the direction of A. So, for the first one, the scalar resolute will be B dot A hat. The resolute parallel to A will be B dot A hat, just swapping this rule and this rule around if I'm doing B in the direction of A, which means my first answer will be B dot A hat. The magnitude of A is the square root of 2 is 4 plus 4 squared is 16 plus 1, or root 21. And A dot B is 2 times negative 3 is negative 6 plus negative 4 times 1 is minus 4 plus 1 times minus 2 is minus 2, which is negative 12. So this is going to equal negative 12 on root 21. So that's the scalar resolute. To find out the vector resolute, it's this bit which I've already worked out, which is negative 12 on the square root of 21 times A hat, which is 1 on the square root of 21 times 2i minus 4j plus k, which is going to equal negative 12 on 21 times 2i minus 4j plus k. Now I can see a simplification there. There's a 3, so minus 4 on 7, 2i minus 4j plus k. Find the vector resolute of B perpendicular to A. So I've got B and I've got A. I'm looking for a resolute of B perpendicular to A will be this vector here. And I know B. And I know this because that's what this vector here is. So I'm going to have, let's call this M. M is going to equal negative of this, so 4 on 7, 2i minus 4j plus k plus B, which is minus 3i plus j minus 2k. And when these put together and combined, this is what the vector which is perpendicular is. And for part D, show that your answers to C and D are perpendicular. Well, if I do the dot product of my answers to C and D, I should get 0. So what have I got? I've got minus 13i on 7, minus 9j on 7, minus 10k on 7, dot. minus 8i on 7 plus 16j on 7 minus 4k on 7. They're all on 7 times 7, so I've got minus 13 times 8 plus minus 9 times 16 plus minus 10 times negative 4, which does give me that, which is 0 on 49, which equals 0.